Which test? Physics, is it? Physics. Yeah, it'll be quite some time. It's still another week, not next week, next to next week. Okay, next to next week, we have time. So we are assuming the electric field actually it's like that. It's going in this direction. This is electric field. And there is a dipole with a minus q. Actually, they don't join. I'm just showing with a join. Like this is kept there. So this field is actually everywhere. Electric field is in an entire place. And you brought this dipole and kept it here. So we want to find out what is the effect and what happens to this dipole. So that's the reason we first write this as a electric field is in this direction, and we say minus q here and plus q here. Intentionally I put as a slanted, so this is how they put as a dotted line. So this distance is 2a, and therefore at the center we have this part a and this part another a. So this is the direction of dipole moment P. It goes from minus q to plus q. P is a dipole moment. Now we want to find out what this E causes, what kind of a force, okay, the force on dipole, right? So this is what we are trying to do with E. So this fellow will have plus q onwards, always force will go along the same direction. This is one force. This another force will be coming this side. Both are equal and opposite. So remember I told you F is equal to EQ. So this F also is EQ, but it will be plus and this will be minus. But in this case, right, they don't cancel out. Remember, like when we talked in mechanics also, right, there is a couple, moment of a couple. In the 10th standard also you got a question, right? So like something gets rotated because of equal and opposite balanced forces and all the things. Remember we talked, if something is fixed at this point, right, it will rotate. So a torque is generated. Okay, so the torque generated due to this, so the torque generated equal to, you are actually getting one QE another QE. That means the torque is generated, that is nothing but QE or EQ, I'll put it UQ multiplied by 2a sine theta. What is this theta? I just said this is at an angle with this horizontal, this is theta. Okay, why they put sine theta? Because we are trying to put along the direction of E. That is why you get EQ to a sine theta. Okay, so this is what is the magnitude of the torque. This is the torque, right? In a vector form they write torque equal to Q cross product E. Okay, this is called a cross product, and this is a vector form. You don't have to, when they are teaching, they teach real complex in physics. This is one suggestion I am telling you. Okay, out of these two, sir, if I write torque equal to this, okay, will you give me marks? I don't write this. Okay, they will give the marks. Vector form not required until, if they ask only, you have to write 1 mark question. Okay, yeah. So that's about the torque in this particular page. Okay, you don't have to write, you don't have to remember or do anything over the remaining stuff. Okay, then we are going to the 1.13. So continuous charge distribution, there are different types of charges. One is called a line charge, another is called a surface charge, another thing is called a volume charge. Okay, so 1.13 charge distribution. What this means is, on a particular line, for example, you may have plus q plus q plus q plus q plus q, so many charges are there. This is called a linear charge distribution if they are on a line. They can be on a surface, plus q minus q plus q plus q plus q, like that. This is called a surface distribution. The third one is a volume. One second, so I'm just trying to get another page added. Yeah. Okay. So this is called a, for example, you have a cylinder. So how the charges are put on the cylinder, all sides. Okay. This is called a volume charge distribution. So what do we mean by distribution? Okay. So distribution meaning how they are distributed. For example, there are three different things. Lambda is equal to total charge divided by the length of the line. This is for the line charge. Okay, what is this lambda called? Is a charge density. We call this as a charge density. This is a line charge density. So what we are doing, total charge divided by length of the line. In case of surface charge density, the symbol is sigma. Here also this is actually delta Q divided by delta L. This will be delta Q divided by delta S. Only this definition is sufficient. You don't need to do anything here. Okay. And if you want the third one, which is a rho, volume charge density, delta Q divided by delta V, volume. So this is how the three formula are there for the charge. This is a surface charge density, CD, charge density, and this one is a volume charge density. Okay, this is a CD, means this charge density. So these are the three things I am picking up from the page 32. You don't need to draw any pictures, you don't need to do anything. These three formulae just need to note down. That's it. Okay. So we have another expression as 1.26. If you want to find out here, for example, we have the formula. You remember these three, right? These three formula, right? So we have a, just now we said E is equal to, electric field is equal to 1 by 4 pi epsilon naught, and then we just said Q by R square, and it goes along the R. This you don't need, right? This is the magnitude. But then just now, for example, this is a line charge. Q is a line charge. Then what we have, charge density lambda equal to whatever Q divided by L. So from here Q is equal to lambda L. So I replace that here. So then E due to a line charge equal to 1 by 4 pi epsilon naught. You replace Q and I put lambda L divided by divided by R square. So if it is a surface charge, then you have same thing, 1 by 4 pi epsilon naught. Instead of lambda L you have sigma, and then S is the surface area divided by R square. If it is a volume, then you will have a rho into volume divided by that. So if you have a delta here, then correspondingly you will have a delta here. That's delta means small, that's all. Okay. This is what the equation you see on the page 33 on the top. Okay, equation 1.26. all right. So I see